With the mathematics, today we're still on the MIT Integration B Qualifying Exam 2010, problems 12, 13, 14, and 15. Problem 12 is the definite integral from x equals to 64 to x equals to 729 of x to the power half over x to the power half minus x to the power third. Problem 13 is the indefinite integral of x to the power x times open bracket 1 plus natural logarithm of x. Problem 14, which is the integral from x equals to 0 to x equals to 1 of x to the power 13 over 2 times the square root of 1 plus x to the power 5 over 2. And problem 15 is the definite integral from x equals to 0 to x tending to infinity of 1 over x squared plus 1 close bracket squared. So join me in just going through this problem. Certainly they look very interesting, and I can't just wait to go through them with you. Thank you. 12, the definite integral from x equals to 64 to x equals to 729 of x to the power half of x to the power half times x to the power third. So the first thing I would do is I would divide both the denominator and the numerator with x to the power a third. So what we're going to do is we have our integral 64 to 729 x to the power half divided by x to the power third over x to the power half minus x to the power a third divided by x to the power third divided by x to the power third. So this obviously cancel out, and we have dx here, and in the numerator we have x to the power half minus a third. Here we have x to the power minus a third. So essentially we have 64 729 x to the power sixth over x to the power sixth minus 1 dx. So this is interesting. We can now say let u be equal to x to the power 6 such that u to the power 6 is equals to x such that 6u to the power 5 du dx is equals to 1, and that means that 6u to the power 5 du can be substituted for dx. And so as we go on, we'll keep solving this. So here we say that let u to the power 6 be equal to x. So we have limits of 64 lower limit, and that means that that is 2 to the power 6. Upper limit is 729, which is 3 to the power 6. And so in this scenario, what that means is that if we're taking everything in the u domain, since we do have 729, 64 lower the power 6 over 6 minus 1 dx. And also from here we see that 6u to the power 5 du will be used to substitute for dx, right? So what this means is that now we have 2 and 3 and u over u minus 1 dx is 6u to the power 5 du. So which is 2 to 3, 6 u to the power 6 over u minus 1 du. We can say maybe let y be equals to u minus 1 such that dy du is equals to 1 and dy can be used to substitute du. Okay. what we have done is we've said let y be equal to u minus 1. That means that at the lower limit, 2 becomes 1, 3 becomes 2, and so 6, we have y plus 1 because we had u to the power 6, and then we have dy, and at the denominator we have y. So using Pascal's triangle, 1, 1, for 2 is 1, 2, 1, for 3 we have 1, 3, 3, 1, for 4 we have 1, 4, 6, 4, 1, for 5 we have 1, 5, 10, 10, 5, 1, for 6 we have 1, 6, 15, 20, 15, 6, 1. So essentially what we have here is the integral from y is equals to 1 to y is equals to 2 of y to the power 6 plus 6 y to the 5 plus 15 y to the 4 plus 20 y to the 3 plus 15 y to the 2 plus 6 y plus 1, all divided by y, and this is dy. Okay, so which is equals to 6 integral from 1 to 2 y to the 5 plus 6 y to the 4 plus 15 y to the 3 plus 20 y to the 2 plus 15y plus 6 plus 1 over y dy. Okay, so now we just go forward and do the integration, and we should be able to solve. We said we had 6 integral from 1 to 2. We have y to the 5 plus 6 y to the 4 plus 15 y to the 3 plus 20 y to the 2 plus 15 y to y plus 6 plus 1 over y dy. And so we have here now 6 y to 6 plus 6 over 5 y to the 5 plus 15 over 4 y to the 4 plus 20 to the 3 y to the 3 plus 15 to the over 2 y squared plus 6y plus log y 1, 2. So quick thing we can do here is just substitute the limits, and so we have 6 2 to the power 6 minus 1 to the power 6 is essentially 64 minus 1 plus 6 over 5 to the power 5 is 32 minus 1 plus 15 over 4. 2 to the power 4 is 16 minus 1 plus 20 over 3. Y minus y to the power 3 is 8 minus 1 plus 15 over 2. 4 minus 1 plus 6. 2 minus 1 plus log 2 minus log 1. Log 1 is simply 0. So this is 63 over 6 plus 31, which is 618 over 5 plus 15 times 15, 150, so I think it's 225 over 4 plus 20 times 7, which is 140 over 3 plus 15 over 2 times 3, this is 45 over 2 plus 6 times 1 is 6 plus log 2. Okay. The answer is, if you do the mathematics very well, is 10,747 over 10, I think, plus 6 natural logarithm of 2. And that is the answer that was provided. So the next problem is problem 13, which is the indefinite integral of x to the power x times 1 plus log x. So we would say let u be equal to x to the power x. What that means is natural logarithm of u is equals to x natural logarithm of x. And so 1 over u du dx is equals to 1 plus, let's say log x plus x, which is the same as 1 plus log x. And so what we can do here now is to say du over u can be used to substitute for 1 plus natural logarithm of x dx, which is this part here. So our integral fx to the power x in the u space is the same as the integral of u and since this part here, so u du over u, which is the integral of 1, which is the same as u plus the integration constant. And since u is from here x to the power x, this becomes x to the power x plus the integration constant. And that is the answer that was needed. So problem 14, which is as shown here. The first thing obviously one would want to do is, so let u be equal to that ugly part, which is 1 plus x to the power 5 over 2. Right? Let me delete this 1 here. Just get it right. So that u squared is equals to 1 plus x to the power 5 over 2. And that means that 2u du dx is the same as 5 over 2 x to the power 3 over 2. And so for the limits, we can say, okay, in the x domain and in the u domain, when we have 0, u is 1 plus 0, square root is 1. And then when u is 1, then when x is 1, u is square root of 2. So in other words, now we do have 0 to 1, x 10 over 2 x 3 over 2, sorry, times the square root of 1 plus x to the power 5 over 2 dx. And so this and this constitute what we have here, right? So this is now equal to 1 to square root of 2. This one here is x to the power 5, which is the same as u squared minus 1 from here, and then we square it so that the half goes away. So we have u squared minus 1 squared, and this part here is u, so it's u, and then we have 2u du. And because there's this 5 over 2 here, we can say there is a constant 2 over 5, so that even if you have a constant here of 5 over 2, this cancel out. So if we had 5 over 2 here, that would cancel out eventually. So that one disappears, so that we just easily inserted this. So we have 2 over 5, and we're pulling this 2 out. The integral from 1 to root 2 of u squared minus 1 squared times u squared. Okay, and this is now equals to 4 over 5 integral from 1 to root 2 of this first part is u to the power 4 minus 2u squared plus 1 u squared du. So let's keep going. So this is equals to 4 over 5 integral from 1 to root 2 of u to the power 6 2 to the power 4 plus u squared du, which is 4 over 5 u to the power 7 over 7 minus 2 over 5 u to the power 5 plus u to the power 3 over 3 1 root 2. So this is the same as 4 over 5 1 over 7 2 7 over 2, so root 2 substituted there, minus 1 minus 2 over 5 2 5 over 2 minus 1 plus a third u 2 3 over 2 minus 1. And I think this is the farthest we can go with that. You can definitely simplify that further, but that's where we'll choose to stop. So problem 15, and this is the last problem for today. What I'll choose to do is I'll say let x be equal to tan theta such that dx is equal to sec square theta. And so if we do the x and the theta, 0 0 infinity tending to pi over 2. So this problem now becomes same as 0 to pi over 2, where we have dx, we'll put that, sec theta d theta. Where we have x, we have tan square theta plus 1 squared, which is 0 to pi over 2 sec square theta d theta. Tan square theta plus 1 is the same as sec square theta. Then since there are 2, well, we have and that cancels. So we have 0 pi over 2, 1 over 6. Theta d theta, and this is the same as cosine theta. So we're gonna we have our integral 1 over 6 theta, which is the same as integral from theta equals to 0 to theta equals to pi over 2 of cosine square theta. So since we know cosine 2 theta is the same as 2 cosine square theta minus 1, so cosine square theta is the same as cosine 2 theta plus 1 over 2. So this one here now becomes 0 to pi over 2 of cosine 2 theta plus 1 over 2 d theta, which goes to a half pi over 2 cosine 2 theta plus 1, which is the same as a half negative sine 2 theta plus theta, 0 pi over 2. Now twice theta, that means twice pi over 2, which is pi. Sine of pi is 0. 2 theta with theta being equal to 0 is 0, so sine 0 is 0. So the only effective variable is going to be theta. So that means we have a half pi over 2 minus 0, which is equals to pi over 4. And that is our final answer today. So that brings us to the end of what we'll be doing today. Until tomorrow, have a wonderful rest of your day. Bye-bye.